Welcome to section 6.3, part 1. This is the 48th session of the CISSP exam prep series. Now we get concrete with the block cipher modes and the named algorithms you must know. In this session, we'll cover how block ciphers run and the classic algorithms. We'll answer several questions. What is a block cipher mode of operation? Why is the simplest mode also the weakest? How do the chaining and streaming modes improve on it? What extra do the authenticated modes provide? And what are the older algorithms you still need to recognize? Why does this matter beyond the exam? Because these modes and algorithms turn up in real configuration screens and audit findings. Picture reviewing a service that still offers an outdated cipher in its settings. Knowing which modes leak patterns and which algorithms are retired lets you flag the risk immediately. It also lets you read a cryptographic configuration and judge whether it is sound or dangerously dated. What is a block cipher mode of operation? It is the recipe for how a cipher processes data block after block. The same core algorithm can be run in different modes, and each mode changes how much protection you actually get. Some modes simply encrypt each chunk in isolation, while others weave chunks together so patterns cannot show through. Think of laying bricks. The bricks are the same, but the pattern you lay them in decides whether the wall is solid or full of obvious seams. Why is the simplest mode also the weakest? Because Electronic Codebook mode encrypts every identical block into the exact same output. That predictability is its downfall. An eavesdropper who sees repeated ciphertext knows the underlying plaintext repeated too, and can slowly assemble a codebook of patterns. So this mode is safe only for very short items, like encrypting a single key. Picture a printer that stamps the same word with the identical stamp every time. Anyone watching quickly learns to read your output. How do the chaining and streaming modes improve on it? They break that predictability by mixing each block with something that changes. Cipher block chaining combines each block with the previous ciphertext using exclusive OR plus a random starting value, so repeats vanish. Its streaming cousins, cipher feedback, and output feedback apply the same idea to real-time data instead of stored blocks. Counter mode goes further, using a simple incrementing counter which lets it encrypt many blocks in parallel for speed. Think of numbering every page before you scramble them, so no two scrambled pages ever look alike. What extra do the authenticated modes provide? They add proof that the data was not tampered with, not just kept secret. The plain modes only deliver confidentiality, so they are called unauthenticated. Galois counter mode and the counter with chaining message authentication code mode go further, attaching an authentication tag to the ciphertext. That tag lets the recipient confirm both secrecy and integrity in one step. So when a design needs to guarantee that a message arrived unchanged, you reach for an authenticated mode. Think of a courier who not only seals the box but also signs a tamper-proof label, proving it was never opened. What are the older algorithms you still need to recognize? Start with the data encryption standard, an early government workhorse. It processes 64-bit blocks using a 56-bit key across 16 rounds of scrambling. That key is now far too short, so it is considered broken and insecure. But it lives on inside a stronger relative, triple DES, which runs the same core 3 times to stretch the effective strength. Triple DES itself is now discouraged and being phased out, though some products still support it. Think of an old lock design that got retired, then briefly reinforced by stacking 3 of them, before finally being replaced entirely. What other classic block ciphers should you know? A few names round out the set. The International Data Encryption algorithm also handles 64-bit blocks, but uses a stronger 128-bit key. And it once powered a popular secure email tool. Blowfish, designed by a well-known cryptographer, works on 64-bit blocks with flexible key lengths and is notably fast, which made it common for secure shell connections. Skipjack, built by a national security agency, used an 80-bit key and, unusually, supported key escrow so authorities could recover keys under legal authority. That escrow feature made the wider community distrust it. Think of 3 tools from the same era, each with its own quirk and reputation. So let's bring it together. A block cipher mode is the recipe that decides how much protection a cipher actually delivers. Electronic Codebook is simplest and weakest because identical blocks map to identical output. Chaining, feedback, and counter modes mix in changing values to erase patterns, while authenticated modes like Galois counter add tamper-proof. Among older algorithms, DES is broken, triple DES is being retired, and the international data encryption algorithm, Blowfish and Skipjack, each carry their own signature traits. Keep these ready as we finish the algorithm lineup next. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.